I would like to discuss completing the square in this video. Before we get into that, let's review a little bit about finding maximum or minimum of a quadratic function. Quadratic function means the highest degree or a highest exponent of a function is 2. So I have ax squared plus bx plus c. This is the general form of a quadratic function. Quadratic means the highest degree is equals to 2, or the largest exponent is equals to 2. So for quadratic function, there is a general form and there is a standard form. In general form, the only thing you can tell using a general form is whether the parabola opens up or opens down. Take a look at the leading coefficient, the number that is right next to the x squared. So a is called the leading coefficient. If a is positive, the parabola opens up just like an U, so opens up. If a is negative, the parabola opens down. So if the parabola opens up, if you look all the way to the bottom of the parabola, do you see that there is a vertex? So that vertex, so right over here. So I am talking about the first picture. So when the parabola opens up, if you look all the way to the bottom, there is a vertex. So that vertex is called the minimum of the parabola. If the parabola opens down, the picture on the right, if you look all the way up, that vertex is the maximum of the parabola. So again, using the general form, you can determine whether the parabola opens up or opens down. If opens up, there is a vertex. The vertex is a minimum. For opens down, the vertex is the maximum. But can you tell me the coordinate of the vertex? Using general form, the answer is no, because I can only tell you up or down, min or max. If you want to tell the specific location of the vertex, you have to use standard form. So take a look on your right hand side, standard form, we have a times x minus x squared plus k. That is called a standard form. In this standard form, I can tell where the vertex is. The vertex stands for h, and then the x coordinate is h, the y coordinate is k. But how do you go from a general form to a standard form? The answer is you have to complete the square. All right, so let's talk about complete the square. So from general form to standard form, you have to complete the square. So starting with a green square. So the green square, the dimension is x by x. So the area is x squared, right? Pretty easy. One side times another side, so x squared. So what I am going to do next is I am going to merge a red rectangle to the green square. The dimension of the red rectangle is b by x. So the width is equals to b, the length is equals to x. So if you merge the red rectangle, just push the red rectangle to the right. So this one, just push that to the right. Do we agree that after you merge both figures, you are not going to get a square anymore, right? So you are going to get a rectangle. So how do you make that red rectangle a square? So to do so, we are going to cut the rectangle into half. So we are going to cut like this. And then we merge one piece right here, and then the other piece right here. So just push those two rectangles to the square. Do you get a square now? The answer is no. What's the problem? The problem is there is a missing square over there. Do you see the purple little square? There is a missing square there. So what is the dimension of the square? So after you cut the rectangle into two pieces, the width is b divided by 2. So as a result, this square, the dimension is half b by half b. So that is the dimension of the purple square. Okay, so what can we do for this purple square? So let's state the area. So the area is equals to b over 2 times b over 2. That is equals to b over 2 square. You don't need to say b squared over 4. You don't need it. So what are we trying to do? We are trying to merge the rectangle to the square, right? Okay, so let's write the expression. So the expression is we have x squared plus bx. So x squared plus bx. So that is a quadratic equation. And then now we are going to merge the purple rectangles in. So we are going to add b divided by 2 square. All right. And then, so if you do so, what happened? So if you do this, that means we already changed the original expression. So let's say I give you x squared plus bx at the very beginning. So if you add another quantity to it, that means you change my problem, right? In order to let this remain unchanged, I have to subtract the same quantity. So we are going to subtract the same quantity. Another way to interpret this is x squared plus bx. So what is x squared plus bx? The x squared stands for, right here, follow my my cursor. So the x squared is the area of the green square, right? And then the bx is the area of the red rectangle. So ax squared plus bx. So if you merge these two together, you have x squared plus bx. But you don't get a big square, right? So in order to get a big square, you have to add this purple rectangle. So the purple rectangle is right over here, b over 2 square. But the problem is you add an extra piece to it. Do you see that? You add an extra piece to it. That means you already changed the area, right? It is supposed to be green plus red, but you add a purple to it. The purple doesn't belong to anywhere. You just add the purple to the entire figure to make that look like a square. So you add an extra piece to it. That means you change the problem, you change the area. So the total area is no longer accurate. In order to let everything remain unchanged, you have to subtract the same quantity. All right, so what is that equal to overall? So there is a way to write this. So first of all, for the parenthesis, I am going to write it like this. So that is equals to parenthesis. You push the square outside. What goes inside? The variable plus the quantity inside the little parenthesis, which is b over 2. What if that is a minus b over 2? Then you have x minus b over 2, and then you subtract the extra quantity, b over 2 square. All right, so that is how you do it. So let me give you an actual example. So let's move on to the next example. So the next example that I would like to give you is, let's say I have f of x equals to x squared minus 6x. I would like you to complete the square. So we call ax squared plus bx plus c. So a is equals to 1, right? A is equals to 1, b is equals to negative 6, c is equals to 0. Okay, so to complete the square, you have to write this for me. You have to do a b divided by 2 square. What is b divided by 2? Look all the way right here, the purple square. That is how I got the b over 2. I need to add this extra piece to it to make the big picture a square. All right. So which is negative 6 divided by 2 square. That is equals to negative 3 squared. That is enough. I know that is equals to 9. Do not write this out. And then we proceed to the next step. So the next step is we have x squared minus 6x, and then we save some space right there. So what we are going to do next, we are going to add and subtract. Add what? Add the extra quantity first, and then subtract the same quantity immediately. That is the only way to let the function remain unchanged. X squared minus 6x. If you don't subtract the extra quantity, then you change the entire problem, then you get a 0. All right, and then now, what is the reason of not writing a positive 9? So here is the reason. You write a big square and big parenthesis, and then you push the square out. First, you drop down the variable, and then you put the number inside the small parenthesis right here. So that is minus 3, right? Then you put minus 3. So if you expand x minus 3 square, you get the top back. All right, and then minus, now you can square the negative 3, and then just write a 9 here. So this one we call the standard form, a times x minus h squared plus k. So what is h? H is equals to 3, k is equals to negative 9, right? So I know my vertex is 3 comma negative 9, and then a is equals to 1. That is positive, so that means the parabola opens up. And then what we can do next is we can draw pictures like that. 3 negative 9, so I supposed to put it right here. So 3 and then negative 9, and then here is my vertex, and then I know my parabola opens up like that. And then how do you find this x-intercept? So at this x-intercept, y is equals to 0. So you simply let y equals to 0 and then solve for x minus 6x, and then 0 is equals to factor out 1x, x minus 6. So I know that x is equals to 0 and x is equals to 6. So this one should go through the origin at x equals to 0. The other one is at x equals to 6. So those are the two x-intercept. Let me give you another example. So the next example is, what if the leading coefficient is not 1? So let's say we have f of x equals to negative x squared plus 2x plus 5. The leading coefficient is not 1. So when the leading coefficient is not 1, you have to factor out the leading coefficient. So let's say you have a negative 10x squared. Then you factor out a negative 10. This time we factor out a negative 1. So that becomes x squared minus 2x and then minus 5. All right. And then what else do we have to do? We have to point out a, b, and c. So inside the parenthesis, a is equals to 1, b is equals to negative 2, and c is equals to negative 5. So this is inside the parenthesis. I am not talking about the negative 1 outside the parenthesis. So let's do this again. What if I have a negative 10x squared at the very beginning? Then you have to factor out a negative 10. So I need this to be 1 in order to start the process of completing the square. Okay, so this is b equals to negative 2, right? So b is equals to negative 2. Then you are going to do your b divided by 2 square. So again, this is the little purple square. The area of the little purple square all the way right here. Okay, right here. So that's why you have to do a b over 2 divided by 10. And then negative 2 divided by 2 square. So that is a negative 1 square. I know that equals to 1. You don't have to tell me that. So f of x is equals to negative 1. And then you have x squared minus 2x. And then minus 5. So save some space. So what we are going to do next is we are going to add this extra quantity. So how about this? So let me do this in red. So I am going to add this plus negative 1 square and then minus negative 1 square. So plus and minus, the problems remain unchanged, right? And then we are going to take this out. We are going to take these two quantity out. All right. Let's write the next line. So the next line is negative 1 and then x squared minus 2x plus negative 1 square. And then what do you get outside of the parenthesis? So this is supposed to be negative 5 minus 1, right? So which is equals to negative 6. So you're supposed to take a negative 6 out. But don't forget that this negative 6 has to multiply the negative 1. All right. So instead of writing negative 6 outside, you have to write a positive 6. Because as you take it out, you have to distribute first. Okay, so we have negative 1. And then what do we have? We have the variable. And then the minus 1 goes down there. All right. And then the plus 6. So what is a, h, and k now? So this is a times x minus h squared plus k. And then a is equals to negative 1, right? And then hk, h is equals to 1, and then k is equals to 6. So this is your vertex. And then this, you have a vertex, a is negative, so that means the parabola opens down, and then you can draw this picture. So at 1, 6, you have this vertex, and the parabola goes down. And then this is the graph, and of course you have two x-intercepts. So this one you do have to this is an x-intercept, right? So at the x-intercept, y is equals to 0. So you let the y equals to 0, negative x squared plus 2x plus 5, and then you have to use quadratic formula because this cannot be factor. All right. So you have let x equals to negative b plus or minus b squared minus 4ac divided by 2a, and then what do you get? So this one, A is equals to -1, B is equals to 2, C is equals to 5. At the end of the day, you are going to get -1.45 and positive 3.45. So this is 3.45 comma 0, and this is -1.45 comma 0. So that's how you go from general form to standard form, because in a standard form, you can see the x and y coordinate of the vertex. So in order to go from one form to another form, you have to do completing the square. All right, so that is the end of this video. If you think my instruction is helpful and clear, give me a like, share the video for me, subscribe to my channel on your way out. I will catch you all in the next one. Signing off for now.